124 light-years from right here, orbiting a dim crimson big call inside the constellation Leo. Something is taking region that might alternate the whole lot we believe we knew approximately being alone. Scientists using the James Webb Space Telescope have detected chemical substances in a far-off surroundings that in the world are made handiest by means of way-of-dwelling subjects. The confidence diploma sits at 99.7%. That leaves only a 3 in 1,000 risk this may be random noise. The planet is referred to as this Ocean International, and its surroundings is screaming with molecules that marine algae pump into our very, very own skies. In case you experience content like this, keep in mind hitting that subscribe button. Prepare yourselves. What comes next will mission every assumption you've got were given about existence inside the universe. Photograph this. A planet crosses in front of its big call. For a few hours, a tiny fraction of starlight passes through the surroundings of that distant worldwide before engaging in us. Internal that mild are secrets and techniques. The James Internet Area Telescope captures this mild and splits it proper right into a rainbow of colors. Every chemical in that surroundings absorbs particular wavelengths. Methane eats up certain reds. Carbon dioxide swallows particular infrareds. Water vapor leaves its non-public signature. Scientists call this transmission spectroscopy, and it definitely works like studying a barcode written in Starlight. This approach is showed generation used successfully on dozens of worlds. Even as the planet transits its celebrity, NET detects the drop in brightness. No knowledge extra importantly, it catches the fingerprints left at the back of via every molecule floating in that alien sky. The way is unique. The telescope sits 1 million miles from Earth, far beyond our atmosphere, wherein not anything interferes with its view. Its mirrors are coated in gold to seize infrared light, the wavelengths wherein those molecular signatures shine brightest. Right here is what makes this innovative. Internet can stumble on chemical materials at concentrations as low as additives consistent with million. On the planet, that might be like finding a single drop of ink in a swimming pool. The statistics comes as graphs displaying dips and peaks at unique wavelength. Every dip represents a molecule absorbing light. Inform the pattern, pick out the chemical. Methane has 4 function absorption bands. Carbon dioxide expertise 2 robust capabilities. Water leaves 3 wonderful marks. The James Internet Space Telescope uses gadgets for this artwork. One is called the near-infrared spectrograph. It appears at wavelengths among 6 and 5, 3 microns. The other is the mid-infrared device analyzing wavelengths from 5 to 28 microns. Collectively, they invent a complete photo of what chemical substances waft in remote atmospheres. Even as scientists aim NET at this ocean global, they expect it to look methane and carbon dioxide. Each have been detected before the use of the Hubble Area Telescope, despite the fact that the older devices struggled with precision. What they found rather made them take a look at their gadgets, 3 instances an entire life. The graph confirmed absorption functions that matched first rate 1 issue, Dimethyl Sulfide, or in all likelihood its chemical cousin, Dimethyl Sulfide. Each molecule's percentage similar spectral signatures in the observed range. The signal appeared at wavelengths amongst 4 and 5, 2 microns. Multiple absorption bands lined up perfectly with laboratory measurements of those sulfur compounds. The electricity of the sign indicated concentrations exceeding 10 components in keeping with million. For reference, Earth's atmosphere is composed of these molecules at plenty much less than 1 element in line with billion. Something in this global have become generating them at 700 of instances an entire life the charge we see right here. Understanding what comes subsequent is even stranger. Scientists ran the observations 2 times the use of 1 among a type units. Each a lifetime the identical signature seemed. The opportunity this happened by using way of random chance sits at 3 cent. That is 3 sigma truth in statistical terms. Not quite sufficient to claim victory, information an extended way beyond coincidence. To acquire 5 sigma, the gold favored for scientific discovery. They need without a doubt or 3 greater commentary home windows. Those should appear inside the subsequent 12-month 700. The subsequent query turns into apparent. What need to probable create those molecules in such remarkable portions? On our planet, dimethyl sulfide has best one showed deliver life, in particular tiny organisms floating within the ocean called phytoplankton. Those microscopic algae produce a compound known as dimethyl sulfonopropionate as they broaden. After they die or a lifetime bacteria damage them down, this compound transforms into dimethyl sulfide. The fuel escapes into the surroundings and you may smell it. Stroll alongside any seaside and that sharp, barely ugly fragrance in the air. This is dimethyl sulfide. Scientists have searched for many years for any non-organic manner to make this molecule in planetary atmospheres. They have got located no longer something that works at full large scales. Laboratory experiments can create trace amounts through reactions among methane and hydrogen sulfide under particular situations. No acknowledge these pathways are inefficient. They require precise ratios of factors and convey dimethyl sulfide at concentrations a long way beneath what we have a look at on the planet, not to mention what Webb detected in this faraway worldwide. Here is why this topics. Maximum biosignature gases have issues. Methane can come from volcanoes. Oxygen may be created while an entire life ultraviolet light splits water molecules. Phosphine may form in violent storms on gas giants. Every of these has at least one regarded abiotic pathway that muddies interpretation. Dimethyl sulfide and its cousin dimethyl sulfide stand aside. Their chemistry calls for specific organic pathways that no appeared geological technique can reflect at high concentrations. The molecule has a brief lifetime. In Earth surroundings, dimethyl sulfide breaks down within days. Daylight tears it apart. Oxygen attacks it. Hydroxyl radicals ruin it. This indicates any dimethyl sulfide we come across must be constantly replenished. In the world, phytoplankton bloom and die in cycles, pumping easy materials into the air. The reality that we are able to measure it in any respect proves a few component is making it constantly. Now, imagine finding this gas on a few different worlds at 10,000 an entire life Earth's concentration. The math becomes unavoidable. Something supply exists, there ought to be fairly powerful. A few processes generating dimethyl sulfide or dimethyl sulfide quicker than chemistry can break it. On this planet, our oceans teem with trillions upon trillions of phytoplankton running throughout the clock. To provide the concentrations internet detected could require life on a scale tough to recognize. Theoretical work published in advance than Webb's observations predicted this precise state of affairs. Scientists modeling hypothetical ocean worlds with hydrogen atmospheres calculated that if existence existed there, dimethyl sulfide would accumulate to a lot higher ranges than within the international. The hydrogen environment ought to sluggish down the destruction pathways. Microbes ought to thrive in heat oceans under. Their waste merchandise would building up a lifetime. The predictions matched observations nearly flawlessly. That is an idea supported through models, no longer no knowledge confirmed truth. Knowledge alignment between prediction and statement makes scientists carefully superb. One researcher at Cambridge said that given everything identified about this planet, an ocean global teeming with life represents the scenario that great suits the information. Know how caution remains the watchword. The subsequent step involves ruling out every alternative explanation, regardless of know how not likely. What if a few aspect else we've got in no way taken into consideration should make those molecules? While scientists say they have got 99.7% self-warranty, they may be speak me approximately records. Especially, they imply the signal they detected has high quality a 3% risk of being random noise. Within the language of facts, this is known as 3 sigma actuality. Image flipping a coin. Get 10 heads in a row, and you would likely suspect the coin is weighted. This is more or much less 3 sigma. Get 20 heads in a row and you will be positive this is 5 sigma. The gold contemporary for claiming clinical discovery sits at 5 sigma. At that degree the danger of mistakes drops below 0.006%. Particle physicists used 5 sigma a lifetime announcing the Higgs boson. Astronomers used it at the same life in entire life confirming gravitational waves for a few aspect as profound as detecting alien life. Nothing much less will suffice. Right now, this discovery sits at 3 sigma. Exciting expertise not conclusive. Proper here is know how they calculated this. The James Webb Space Telescope accumulated information displaying absorption talents at precise wavelengths. Scientists then compared this statistics towards models. One version assumed dimethyl sulfide or dimethyl sulfide gift within the atmosphere. Each different model assumed those molecules have been absent. The model with the sulfur compounds healthy, the data notably better. Statistical exams discovered out that the possibility of getting this correct in form with the resource of risk, if the molecules were now not certainly their equals. Recent understanding chance is not the high-quality issue. Systematic mistakes can idiot devices. Perhaps the telescope's calibration drifted barely. Perhaps thermal noise created fake indicators. Perhaps the celebrity itself has unusual houses that mimic the signature of dimethyl sulfide. Scientists spent months checking for those possibilities. They used 2 unique contraptions on net. Every noticed the same signal. They tested observations of other planets to make certain the signature became precise. They modeled dozens of alternative atmospheric compositions. Nothing else fit as nicely. To gain 5 sigma, they need greater statistics. Every declaration window lasts about 8 hours as the planet crosses its big name. They've got used 2 domestic home windows up to now. Scientists estimate they need or 3 more. That means a few different 16 to 24 hours of telescope life, time spread all through a couple of transits. The planet completes an orbit every 33 days, so opportunities get up often. Know how net is the most oversubscribed telescope in history. Thousands of astronomers compete for a lifetime. Getting approval calls for a rigorous preference approach. The lead researcher said they have formally carried out for extra statement a lifetime. An examined panel will determine whether the generation justifies the fee. If legal, confirmation may also want to come back inside 765 days. That a life timeline places us probably 112 months far from expertise, whether or now not we have detected alien lifestyles. 700 far away from answering humanity's oldest query. Are we by myself? Understanding right here is what makes this second electric powered. Even at 3 sigma, in spite of uncertainty remaining, we were given crossed a threshold. For the primary life time in records, we've facts from every different international that is less difficult to provide an explanation for with lifestyles than without it. That has in no way came about before. What makes this worldwide unique sufficient to offer this type of sign? The planet orbits a superstar referred to as a crimson dwarf. Those stars are smaller, cooler, and dimmer than our Sun. This specific crimson dwarf has a temperature of about 394 degrees C. Our Sun burns at 500 degrees. The crimson dwarf incorporates nice 45% of our solar's radius. Less mass, much less warmth, much less slight. Expertise right here is the trick. The planet orbits a brilliant deal towards compensate. Earth sits 93 million m from the Sun. This ocean international orbits truly 13 million miles from its superstar. That places it 167 lifetimes closer than Earth relative to its star's duration. Distance topics extra than you might imagine. The intensity of starlight follows the inverse square law. Double your distance, and also you get preserve of 1/4 the mild. Past 10 instances an entire life nearer, and also you get 700 a life time greater mild. This planet orbits so near that regardless of its star's dimness, it receives more or less the identical amount of energy Earth does. Scientists call this the habitable sector. Its farther region spherical any big name wherein a planet with the proper ecosystem need to maintain liquid water on its surface. For our solar, that area spans from about 90 million to about 700 million miles. For purple dwarfs the habitable region sits plenty nearer. A life to me an entire life only some million miles out. This showed with the useful resource of a life, time of observations and weather modeling. Temperature is not just about distance. Atmospheres trade the whole thing. A planet with a thick surroundings traps warmth through the greenhouse effect. Carbon dioxide and methane are in particular correct at this. Water vapor enables too. The right mix can hold international heat even far from its movie star. Venus demonstrates this principle long past wrong. Regardless of being towards the Sun than Earth, Venus would be cooler if not for its crushing carbon dioxide environment. As an alternative, ground temperatures attain 470 degrees C. This ocean international has a hydrogen-wealthy environment. Hydrogen is much less green at trapping warmness than carbon dioxide. Know how it makes up for this with sheer volume. Fashions propose the environment would possibly represent up to 6% of the planet's overall mass. For contrast, Earth's ecosystem is less than 1/1,000,000th of our planet's mass. That plenty hydrogen creates a robust greenhouse effect, no matter decreased performance in line with molecule. Information right here comes a trouble. The equal closeness that lets in liquid water additionally brings danger. Crimson dwarfs are violent stars. They produce effective flares, surprising bursts of radiation, and charged particles that blast close by planets. The one's flares can strip away atmospheres over 700 of years. They shower planets in ultraviolet and X-ray radiation that destroys complex molecules and sterilizes surfaces. Yet this world seems to have retained its environment. Observations know how considerable hydrogen, methane, and carbon dioxide. If the well-known person had been continuously stripping surroundings away, we'd see signs of atmospheric loss. The presence of heavy molecules expertise the planet has held onto its envelope for a lifetime. In all likelihood, its strong gravity lets in. Likely the environment is thick enough to weather the storms. Or perhaps we are witnessing some factor special, a planet in a brief window before its surroundings disappears. The superstar itself is anticipated to be 2.4 billion years antique. Earth is 4.1 of billion years antique. This Celeb machine is type of half of our age. Younger sufficient that the planet may nevertheless be geologically energetic. Antique sufficient that any lifestyles might have had a life, time to comply. What takes place a life, time you integrate those sorts of elements with the strangest characteristic of this global. One orbit takes 33 Earth days. That means a 37700 there lasts sincerely over a month. Take into account celebrating your birthday 33 a lifetimes faster. You'll be over 1,000 years vintage a life, time you reached your 30th birthday through Earth requirements. Understanding but this pace has consequences that ripple via every element of the planet's behavior. First, do not forget seasons. On the Earth, seasons stand up because of the fact our axis tilts 23 degrees. Even as the northern hemisphere tilts towards the sun, we get summer season. 6 months later, we tilt away and get iciness. This ocean worldwide probable has minimum axial tilt. That means seasons may want to not show up the way we enjoy them. As an alternative, any climate variant comes from the orbit itself. Here is wherein matters get exciting. The orbit isn't always flawlessly circular. Scientists agree this the use of a spread of known as eccentricity. Earth's orbit has an eccentricity of 0.17, almost an extraordinary circle. This ocean global has an eccentricity of about 0.9/5 a life, time extra elliptical. This is showed through precise measurements of orbital timing, which means that the space from the star adjustments appreciably a lifetime in the futurian entire life of each orbit. At the closest point, the planet sits about 12% nearer to the movie star than at the farthest point. That may not sound like masses. Expertise inverse rectangular regulation amplifies this difference. The planet gets about 43% extra starlight at closest method in assessment to farthest distance. Consider if Earth's weather swung that wildly. Each few weeks, temperatures may spike and crash in cycles. Any water at the floor could face normal freeze-thaw cycles. This creates a balanced trouble. Existence as we are aware about it requires stable temperatures. Severe swings make it hard for complicated chemistry to set up itself. Water may freeze at one part of the orbit, then boil at a few different. Organisms would possibly need to stay on both extremes inside an unmarried month. Within the international, extremophiles bacteria can handle wide temperature tiers. Some thrive in boiling warm springs. Others live on in Antarctic ice. No knowledge asking organisms to cope with both extremes on a month-to-month agenda is a tremendous challenge certainly. But the Dimethyl Sulfide signal persists. If lifestyles exists there, it has adapted to this chaotic rhythm. Possibly the thick hydrogen ecosystem acts as a buffer, smoothing out temperature extremes. Perhaps lifestyles retreats to deeper waters at some stage in temperature swings, searching ahead to situations to stabilize. In all likelihood, the oceans themselves save sufficient warmth to save you wild fluctuation. There's every other hassle with speedy orbits. A lifetime a planet orbits this near its celebrity, gravitational forces turn out to be excessive. The celebrity pulls harder at the near factor of the planet than the protracted mana component. Over 700 of thousands of years, this difference in pull creates tidal forces that graduate the planet's rotation. Finally, the planet turns into tidally locked. One face it commonly faces the famous character in everlasting sunlight ours an entire life. The opposite side faces away in eternal darkness. Scientists suspect this ocean international is tidally locked, although this remains unconfirmed. If proper, the day side is probably scorching heat. The a life to me an entire life face it might be frozen strong. Simplest a slender twilight band between the two hemispheres might hold temperatures suitable for liquid water. Wind might expertise in the course of this boundary as hot air from the dayside rushes to fill the frigid night a lifey an entire life side. Weather styles could be in contrast to something we see on this planet. Understanding what if the thick hydrogen environment adjustments the game. Laptop models expertise that a dense surroundings can deliver warmth from dayside to a time aspect correctly. This will create greater habitable situations throughout large quantities of the ground. Without seeing the planet without delay, scientists can most effective estimate these outcomes. What they know for certain is this global is not anything like Earth in phases of day-night cycles. How does a planet 2/2 of a lifetime's Earth duration maintain situations that would help existence? The planet has a radius 2.6 an entire life massive than Earth. That makes it massive. Its volume is over 17 a lifetime's hours. If you may stand at the floor, assuming there is a surface, gravity might crush you at about 2/2 of a lifetime Earth's electricity. Each step would experience like carrying another reproduction of yourself in your lower back. This is showed via specific measurements of the planet's mass and size derived from orbital mechanics. Expertise length creates a problem. Planets this big generally do not appear to be Earth. They appear like Neptune. Our solar device has 4 rocky planets and 4 gas giants with not something in between. This ocean international sits precisely in that hole. Scientists call planets like this sub-Neptunes. They are larger than Earth knowledge, smaller than Neptune. We have positioned plenty of them round other stars. No knowledge we've none in our personal tool to have a take a look at up close. Here is the mystery. We do not realize what sub-Neptunes are product of. Are they rocky planets that captured massive atmospheres? Are they icy worlds like Neptune that in no way grew massive sufficient to grow to be complete fuel giants? Are they something else genuinely? A type of planet that does not exist in our solar system? The answer determines whether or not existence have to stay to tell the tale there. The density offers clues. Earth has a density of 5G consistent with cm. That is because we're typically iron and rock. Neptune has a density of 1.6G in keeping with cm. That is due to the reality Neptune is normally water, ammonia, and methane ices wrapped in hydrogen and helium gasoline. This ocean world has a density of 2.67G in step with cm, proper between Earth and Neptune. One opportunity is this. The planet has a rocky middle, perhaps 3 to 4 lifetimes Earth's mass. Above that sits a mantle of high-stress ice. Now not the ice you find for your freezer. Know how ice that paperwork beneath intense strain and remains sturdy even at immoderate temperatures. Above that might be liquid water, and above that a thick environment of hydrogen and helium. This structure is solely theoretical, a model made from mass and density measurements. No person knows for sure. This version results in the concept of Hycean worlds. The phrase combines hydrogen and ocean, the idea understanding planets with hydrogen atmospheres and liquid water surfaces will be livable notwithstanding being heaps larger than Earth. The hydrogen environment may entice warmth through greenhouse warming. The liquid water offers a medium for lifestyles. Microbes need to go with the glide in those oceans similar to phytoplankton drift in Earth's seas. Know how critics issue out troubles with this photo. On the floor pressures predicted on one of these big planets, water may not stay liquid. It exists in a supercritical US, wherein the difference among liquid and fuel breaks down. Do not forget water that flows like liquid. Understanding Jevic knowledge as the density of steam.
That you, sir.
Begins above 374 degrees C and above 221 a life to me a life an entire life Earth's atmospheric strain. If the surface temperature or stress exceeds those thresholds, liquid oceans cannot exist. Some scientists argue this world is simply too heat. Climate fashions endorse that with its thick hydrogen environment and the quantity of starlight it gets, floor temperatures may need to exceed 500 degrees C. At that temperature, any water may want to exist as supercritical fluid or steam. The surface is probably molten rock, a magma ocean wrapped in a hydrogen blanket. If so, the dimethyl sulfide signal dreams a unique clarification. Information distinctive models inform a fantastic story. They recommend that if clouds shape in the top environment, those clouds need to reflect enough starlight to preserve the floor cool, and albedo, the degree of reflectivity, above 9% should preserve liquid water. Whether such clouds can form stays unsure. The chemistry of hydrogen-rich atmospheres makes cloud formation one of a kind than on the Earth. What makes the absence of shore molecules an essential clue. Earth's oceans incorporate about 25 trillion phytoplankton. Those microscopic organisms go with the flow inside the sunlit surface waters. The usage of photosynthesis, information, carbon dioxide, and daylight hours into electricity. They produce more or less half the oxygen we breathe. They form the lowest of the oceanic meals chain, and they make dimethyl sulfide when you go to the seashore. That particular scent inside the air comes largely from the one's tiny beings. Phytoplankton create a compound referred to as dimethyl sulfonopropionate to adjust salt balance of their cells. It acts as an osmolyte, assisting them cope with the saltiness of seawater. Whilst the phytoplankton die, or even as bacteria assault them, enzymes harm down this compound. One of the breakdown products is dimethyl sulfide. The gas escapes into the environment at a fee of approximately 700 million lots of 700 constant with 12 months globally. That is showed technological beded 540 11 C7500 Zab C3054 measured immediately through atmospheric sampling and satellite TV for laptop observations. The molecule does not last prolonged. Hydroxyl radicals within the ecosystem assault it within days. Sunlight breaks it apart. It oxidizes into sulfur dioxide, then sulfuric acid, which forms tiny particles. Those particles seed clouds. More clouds advise extra sunlight hours an entire life contemplated back to place, cooling the planet. Some scientists advocate this creates a feedback loop. Warmer oceans produce extra phytoplankton. Greater phytoplankton make greater dimethyl sulfide. Greater dimethyl sulfide creates more clouds. Extra clouds cool the planet. This speculation remains unproven, how broadly cited. Now don't forget what it method to come across dimethyl sulfide on a few different international. The sign requires non-prevent manufacturing. A few issue want to churn out the molecule faster than chemistry destroys it. Within the global, the combined efforts of trillions upon trillions of phytoplankton cells barely maintain atmospheric concentrations of one detail constant with billion. To attain 10 elements in step with million, the I determined in this ocean global requires a production rate 10 xalos and a lifetime better. What may want to probable do that? One option is absolutely greater phytoplankton. If the oceans there contain hugely extra microbial life in line with unit volume than Earth's oceans. The maths works, understanding, but why might that be? In all likelihood, the mixture of hydrogen atmosphere and liquid water creates best conditions for microbial blooms. Probable nutrients are more plentiful. Possibly the dearth of predators permits populations to explode unchecked. A few different alternative includes different chemistry. Possibly organisms there produce dimethyl sulfide at once instead of as a byproduct. In the international, phytoplankton make dimethyl sulfonopropionate for one cause and dimethyl sulfide takes place as a facet effect. On every other worldwide, lifestyles can also use dimethyl sulfide as a signaling molecule, a metabolic product, or maybe a waste made from strength error. Special evolutionary pressures could result in tremendous uses for the equal molecule. There may be moreover the question of bacterial contribution. In the world, bacteria play a huge function in changing dimethyl sulfonopropionate into dimethyl sulfide. Wonderful bacterial species recognition on this variation. An ocean full of those microorganisms feasting on herbal rhyli may additionally want to supply sizable large portions. The dimethyl sulfide detected alongside dimethyl sulfide facilitates this. On Earth, dimethyl sulfide comes in most instances from bacterial metabolism, no longer phytoplankton right away. The smell the one's molecules produce is strong and unsightly. At immoderate concentrations, dimethyl sulfide reeks of rotting greens or decaying seaweed. Some describe it as garlicky or sulfurous. If you may by a few way visit this Ocean International and breathe the environment, assuming the hydrogen did not kill you first, the stench is probably overwhelming. Believe status downwind of a massive algae bloom protective 700 loads of 700 of rectangular miles, all releasing dimethyl sulfide right away. That's what this planet's air might smell like. Expertise odor is the least interesting element. The actual query is what this molecule tells us approximately the opportunity of life. On Earth, we've searched for a few years for any non-organic way to make dimethyl sulfide at sizable concentrations. We have determined not whatever. Each pathway calls for living cells. If the equal holds actual on this faraway global, then we are detecting lifestyles' chemical signature written in Starlight. How ought to concentrations be 10 zallosan instances an entire life higher than Earth's? Earth's environment includes dimethyl sulfide at much less than one element in line with billion through quantity. Pattern air from above the sea and you'll discover it, understanding barely. The molecule breaks down short. Its life-year lifetime in our environment averages approximately 1 day. This is confirmed through cautious atmospheric chemistry research. Sunlight assaults it. Hydroxyl radicals tear it aside. Oxygen converts it into sulfur dioxide. The most effective motive we detect it in any respect is because of the truth phytoplankton continuously top off the supply. This ocean global information concentrations exceeding 10 additives in step with million. That is more than 10,000 a lifetime better. To position this in angle, consider if carbon dioxide in the world suddenly jumped from 700 factors in keeping with million to over 4 million elements in line with million. The complete planet should emerge as uninhabitable inside days. Expertise dimethyl sulfide isn't always carbon dioxide. It does not force greenhouse warming the same manner. Its primary effect is chemical, no longer thermal. What should give an explanation for such excessive concentrations? One possibility includes the hydrogen environment itself. On the planet, oxygen dominates our surroundings at 21%. Oxygen is surprisingly reactive. It destroys dimethyl sulfide efficaciously. This Ocean International has a hydrogen ecosystem with minimum oxygen. Hydrogen is a good deal less reactive in the direction of dimethyl sulfide. The destruction pathways that paintings within the International may not paintings there. The molecule ought to final weeks or months in preference to days. Longer life-year lifetime method a lot less manufacturing had to maintain high concentrations. If dimethyl sulfide survives 10 a lifetime longer, you want simplest fervent 10th the production rate to attain the identical interest. If it survives 700 a life in entire life longer, you want 700 the manufacturing fee. Scientists modeling this Ocean International calculated that in a hydrogen surroundings with excessive carbon dioxide and occasional oxygen, dimethyl sulfide must persist a bargain longer than on this planet. This is theoretical. Understanding of knowledge based totally mostly on hooked up atmospheric chemistry principles. Know how even accounting for longer life a lifetime, the numbers are outstanding. 10 additives according to million calls for huge production. One studies group predicted you will want a biogenic flux, the rate at which organisms produce the fuel 700 of a lifetimes more than Earth's oceans provide. That understanding either a long way more lifestyles in line with unit quantity or some distance extra green dimethyl sulfide manufacturing pathways or every. Right here is in which the carbon dioxide connection topics. Internet detected approximately 1% carbon dioxide in this planet's atmosphere. That is 25 a lifetime higher than Earth's 700 elements in step with million. Immoderate carbon dioxide stages can affect expertise organisms metabolize sulfur compounds. A few bacteria within the global use carbon dioxide of their metabolic pathways. Probably in this ocean global, The abundance of carbon dioxide drives special biochemical pathways that produce greater dimethyl sulfide in line with cell. There is another factor. Temperature affects chemical reaction costs. Hotter water method, quicker metabolism. If the oceans there are warmer than Earth's, organisms may also expand faster, reproduce faster, and produce waste merchandise faster. The common temperature of Earth's oceans is ready 3.5 C. Models advise this ocean international surface may additionally need to range from 10 degrees to over 50 degrees C, counting on cloud cowl and greenhouse strength. At 30 degrees, organic strategies run numerous a lifetime quicker than at 3 degrees. Combine some of those factors: a hydrogen surroundings that slows dimethyl sulfide destruction, excessive carbon dioxide riding altered metabolic pathways, warm oceans accelerating organic techniques, doubtlessly higher biomass density than Earth's oceans. The multiplication of consequences can also want to provide an explanation for why concentrations are lots higher. Each problem alone could probably offer a 2 or 5 growth. Together they multiply, not add. 2 to 5, 3, 4 equals a 720 instances an entire life. Upload a few greater factors and you reap tens hours and a lifetimes. Expertise critics ask a different question. What if the immoderate concentrations prove the sign isn't organic? What if there's an abiotic, non-dwelling chemical pathway that produces dimethyl sulfide effectively in hydrogen atmospheres? Laboratory experiments have explored this. Scientists blended methane hydrogen sulfide and exposed them to ultraviolet mild. They created trace portions of dimethyl sulfide. Information hint quantities recommend elements in keeping with billion, no longer components in line with million. The experiments fall short with the resource of things of thousands. A molecule with any such brief leafier lifetime continue to exist lengthy enough to be detected. Every molecule has 455 AD77 AB1D34 sen of 6 CFO 33608. The not unusual and entire life it exists earlier than breaking aside. For dimethyl sulfide in Earth's surroundings, that life a lifetime is brutally brief. One have a look at measured it at 24 hours. Some other located 48 hours. The variant relies upon community situations like daylight depth, temperature, and the abundance of oxidizing chemical materials. Understanding stop remains the same. Dimethyl sulfide does not final lengthy. That is confirmed generation replicated in several studies. 3 essential procedures damage dimethyl sulfide on this planet. First, hydroxyl radicals attack it. The one's radicals are molecular fragments with unpaired electrons, making them noticeably reactive. They shape a lifetime as ultraviolet mild breaks apart water molecules inside the top surroundings. Once shaped, hydroxyl radicals attack almost any natural molecule they come upon. They capture hydrogen atoms, breaking chemical bonds. Dimethyl sulfide has 6 hydrogen atoms ripe for taking. 2D oxygen immediately reacts with dimethyl sulfide. The response is slower than with hydroxyl radicals, understanding of a knowledge, still big. Oxygen combines with the sulfur atom creating sulfur dioxide, because the first step. Subsequently, this pathway leads to sulfuric acid formation. That is why burning sulfur containing fossil fuels creates acid rain. The sulfur will become sulfur dioxide, then sulfuric acid, then falls as precipitation. The same chemistry happens to dimethyl sulfide certainly within the surroundings. 1-3, daylight itself can spoil dimethyl sulfide apart. Picture dissociation takes area whilst a photon includes sufficient electricity to snap chemical bonds. For dimethyl sulfide, ultraviolet wavelengths among 700, 700 and 300 nanom do the harm. These wavelengths convey sufficient punch to interrupt the carbon-sulfur bonds retaining the molecule together. The pieces fly apart and recombine with different atmospheric chemical materials. Now take into account a hydrogen surroundings. Hydroxyl radicals nevertheless shape how a whole lot less effectively. Hydrogen atmospheres encompass much less water vapor to interrupt aside. Much less water vapor approach fewer hydroxyl radicals. Fewer radicals mean a slower destruction of dimethyl sulfide. Fashions suggest the hydroxyl radical interest on this ocean worldwide's environment is probably 1/10 or 7/100 of Earth's levels. Oxygen offers even more dramatic variations. This ocean international has minimal oxygen. Spectroscopic observations expertise no detectable oxygen talents, which means the direct oxidation pathway that destroys dimethyl sulfide on Earth does no longer work there. Doing away with one critical destruction course automatically extends the molecule's life an entire life. Photodissociation nonetheless occurs. The planet Scilla puts out ultraviolet mild, even though pink dwarfs emit much less UV than our Sunday. The hydrogen surroundings itself might in all likelihood soak up a few UV earlier than it reaches decreased altitudes in which dimethyl sulfide concentrates. Methane and carbon dioxide moreover take in shore UV wavelengths, offering extra shielding. The net effect is that dimethyl sulfide tails much less photochemical strain. Placed all this together, and dimethyl sulfide may stay on 10 a life to Lephine entire life longer, likely 17700 a life, time longer than in the world. In preference to at least 1 or 2 days, it would final weeks or months. That transforms the manufacturing necessities. If you only want to refill the molecule every few weeks in preference to every day, you need plenty much less biological interest to keep the identical atmospheric attention. A problem of 10 in life a lifetime reduces production necessities by using manner of a detail of 10. Understanding of a knowledge here is the entice. Despite a 700 a lifetime's longer life a lifetime, you still need good-sized production to preserve 10 components consistent with million. The arithmetic is unavoidable. Something on this global generates dimethyl sulfide at quotes that dwarf a few element we see on Earth. The extended life a life time allows provide an explanation for expertise. The attention stays so high, information it does not remove the want for effective supply. Scientists are seeking to pin down unique life a lifetime numbers through precise atmospheric modeling. They input the found concentrations of methane, carbon dioxide, and hydrogen. They calculate photochemistry response by reaction, monitoring knowledge every molecule interacts with others. They estimate UV flux from the massive name. They model temperature and pressure at distinct altitudes. The quit end result is a prediction of dimethyl sulfide life time under those particular conditions. Early fashions advise Lephine entire lives amongst 10 and a 700 days. Understanding uncertainty stays huge. What may additionally want to provide and reason behind those signals without invoking life in any respect? No longer anyone believes the dimethyl sulfide sign-way existence. A growing quantity of scientists factor to an opportunity rationalization. What if this global has no oceans at all? What if the floor is molten rock wrapped in a hydrogen surroundings? Magma oceans have to produce some of the equal chemical signatures as dwelling oceans. This alternative clarification comes from particular weather modeling posted in early 2024. Here is expertise magma oceans may work. The plan of Phi 55 stay 3508 65 165 and 30 Starlight notwithstanding orbiting a dim crimson dwarf. A thick hydrogen atmosphere creates a effective greenhouse effect. Despite the fact that hydrogen isn't always as inexperienced as carbon dioxide at trapping warmth, sufficient of it creates severe warming. Models recommend floor temperatures must exceed 800 degrees C underneath these conditions. That is theoretical, primarily based mostly on electricity balance calculations and stated atmospheric properties. At those temperatures, rock melts. Granite melts around 1700, basalt melts around 1700 degrees, but rocks are complex combos. A few minerals soften at decreased temperatures. A planetary surface at 800 degrees should not be completely molten. Understanding it is able to have extensive lava flows, lava lakes, and molten areas protecting massive fractions of the floor. Image O, Jupiter's volcanic moon, information scaled up to 2 and 1b2 a lifetime Earth's size. Magma interacts with atmospheres in complex tactics. Volcanic gases bubble up through molten rock. Those gases embody water vapor, carbon dioxide, sulfur dioxide, and hydrogen sulfide. Whilst hydrogen sulfide enters a hydrogen-rich surroundings, chemistry takes area. At excessive temperatures, hydrogen sulfide can react with carbon-containing molecules to form organic sulfur compounds. Laboratory experiments have established this. The yields are low. Knowledge continuous volcanic outgassing may also need to keep consistent production. One studies group ran the numbers. They modeled a planet with a magma floor, a hydrogen surroundings and volcanic outgassing prices, just like Earth's maximum lively volcanic intervals. Their version produced dimethyl sulfide through abiotic chemistry. Understanding concentrations fell short with the aid of elements of 10 to 7, 100 in comparison to observations. They could make dimethyl sulfide without lifestyles. Know how now not enough of it. The distance information biology might probable although be needed. Information it does not rule out more appropriate volcanic strategies we do no longer really recognize. There can be every other clue. Ammonia. On this planet, nitrogen-rich atmospheres produce ammonia, a lifetime lightning, or different strength sources combine nitrogen with hydrogen. Ammonia is likewise produced with the resource of life. Many bacteria generate ammonia as a waste product. Fashions are expecting that a livable ocean worldwide want to have detectable ammonia. Understanding observations knowledge none. The absence of ammonia is showed through spectroscopic analysis. Magma ocean models provide an explanation for the lacking ammonia clearly. Nitrogen dissolves into molten rock below high stress. The technical life time is nitrogen partitioning into the melt section. If the floor is molten, atmospheric nitrogen gets absorbed into the magma. This depletes ammonia from the surroundings. You become with a planet that has nitrogen locked within the floor rather than floating in the air. This matches observations perfectly. Ocean international fashions conflict with the missing ammonia. If liquid water exists on the floor, nitrogen need to stay in the surroundings. Ammonia need to form through chemical reactions and biological strategies. Its absence becomes a puzzle. Some scientists argue that positive metabolic pathways may also need to eat ammonia as rapid because it paperwork. Know how this calls for particular situations. The magma ocean clarification is less complicated. It calls for no precise biology, simply primary chemistry. Expertise magma ocean fashions face their non-public stressful situations. They struggle to offer a cause of the methane detected inside the surroundings. Methane should now not be solid at immoderate temperatures. It breaks down into carbon and hydrogen above about 700 degrees C. To maintain 1% methane within the environment requires either non-stop manufacturing or cooler temperatures than magma ocean models are awaiting. Each preference creates problems for the magma ocean speculation. The controversy continues. A few scientists pick out the magma ocean rationalization because it explains missing ammonia. Others favor the sea world rationalization as it explains plentiful methane and dimethyl sulfide. Each camps agree extra observations are needed. The following round of net observations would possibly locate one of a kind molecules that settle the query. Certain chemical compounds might only exist in magma conditions. Others ought to quality exist with liquid water. What if the planet does have water? Understanding surroundings is more alien than all and sundry predicted. Hydrogen dominates this planet's surroundings. Spectroscopic observations confirm this. The absorption features, the way starlight gets filtered, all factor to massive amounts of hydrogen and helium. This creates a crucial problem for life as we recognize it. Earth's surroundings is 78% nitrogen, 21% oxygen, and simply trace quantities of various gases. No hydrogen in any respect at floor degree. Hydrogen is simply too light. It escapes Earth's gravity and drifts into space. Information this ocean international is extra massive. Its stronger gravity holds onto hydrogen. Lifestyles on the planet advanced in a nitrogen-oxygen surroundings. Our proteins, our enzymes, our cellular machinery all expect sure atmospheric chemistry. Oxygen serves as the very last electron acceptor in respiratory, the method that powers most complicated lifestyles. Without oxygen, you are confined to anaerobic metabolism. That works exceptional for bacteria and some easy organisms. No knowledge complicated multicellular lifestyles, the kind that builds civilizations, desires oxygen or something equal. A hydrogen surroundings adjustments the whole thing. Hydrogen isn't just inert like nitrogen. It actively participates in chemistry. It reduces distinctive molecules, the alternative of oxidation. This impacts what chemical reactions are feasible. A few reactions that preserve effortlessly in oxygen-wealthy atmospheres grow to be difficult or not feasible in hydrogen-wealthy ones. Different reactions that never seem in the world grow to be favorable. Information here is the surprising factor. Life may not simplest tolerate hydrogen atmospheres, expertise thrive in them. Modern-day laboratory experiments tested whether or not Earth microbes need to live on in natural hydrogen. The consequences stunned researchers. Microorganism and yeast that usually in no way stumble upon hydrogen grew simply excellent whilst exposed to 700% hydrogen atmospheres. That is confirmed experimental information published in peer-reviewed journals. The organisms did now not grow quicker, understanding they did not die both, they tailored. Hydrogen offers metabolic possibilities. Some microorganisms on the Earth use hydrogen as a strength source. They integrate hydrogen with carbon dioxide to make methane, gaining electricity inside the gadget. Those methanogens stay in deep-sea vents, in swamps, within the guts of animals. They expertise that hydrogen-based totally metabolism works. On a planet with abundant atmospheric hydrogen, these metabolic pathways may additionally dominate. The query turns into whether complicated organisms can evolve in such environments. Inside the International, the soar from unmarried, celled to multicellular lifestyles coincided with rising oxygen degrees. The splendid oxidation event too. 4 billion years in the past stuffed our surroundings with oxygen from photosynthetic microorganism. Inside a few 700 million years, complicated lifestyles emerged. Correlation does not prove causation, no, how timing is suggestive. A few scientists argue that oxygen's high strength density makes it first class for powering complicated life. Others argue that any sufficiently lively metabolism may also need to work. Hydrogen metabolism gives plenty much less electricity in step with response than oxygen metabolism. Know how it still offers power. Perhaps complex existence evolves extra slowly in hydrogen atmospheres. Perhaps it takes distinctive bureaucracy. Perhaps it in no way gets beyond microbial colonies. We do now not understand because of the truth we have. We're given most effective one example of existence to look at. The hydrogen environment in this ocean international probable got here from the planet's formation. At the same a life in entire life planet's shape, they accrete fuel from the encircling nebula. Huge planets capture greater gas. If a planet grows large enough, brief enough, it captures big quantities of hydrogen and helium earlier than the star's radiation blows away the nebula. This ocean worldwide in all likelihood captured numerous Earth 700 of hydrogen all through formation. This is theoretical information well supported with the resource of planet formation fashions. A lifetime atmospheric escape slowly strips away hydrogen. Excessive energy debris from the star knock hydrogen atoms out of the top surroundings. They benefit enough speed to conquer the planet's gravity and go with the flow away. Pink dwarf stars produce common flares that boost up this manner. Expertise. This world retained its hydrogen atmosphere over billions of years. That expertise, both the planet is more youthful, or the surroundings is thick sufficient to climate the losses. The thickness topics for habitability. A skinny hydrogen surroundings should now not lure a exquisite deal warm temperature. A thick one creates severe greenhouse warming. The project is locating the right balance. Too thin and any liquid water freezes. Too thick and ground pressures end up crushing. Models recommend this planet sits close to the brink of habitability. Small changes in atmospheric mass ought to tip it from habitable to uninhabitable. Why perform a little scientists suppose this international resembles Neptune greater than Earth? Neptune has a radius approximately 4 a life an entire life larger than Earth. Its mass is 17 a lifetime hours. Its environment is in popular hydrogen and helium with about 2% methane. Deep under the surroundings lies a mantle of water, ammonia, and methane ices. Deeper nevertheless, a rocky middle in all likelihood barely bigger than Earth. Neptune isn't always a gas massive like Jupiter. It's miles and ice huge, dominated by way of the usage of unstable compounds in preference to hydrogen fuel. This ocean global stocks many trends with Neptune no matter being smaller. The density tells a part of the tale. Neptune's density sits at 1.6 g in step with cm. This ocean worldwide measures 2.67 g in keeping with cm. Earth is 5 g consistent with cm. The development is obvious. This planet falls among Neptune and Earth in density. Smooth calculations snoke knowledge it need to incorporate a great deal less rock than Earth, an extra rock than Neptune. Know how what fills the space. Indoors shape fashions offer solutions. Scientists input the found mass and radius. They add constraints from planetary technology. Rocky materials have high quality densities. Water ice beneath stress has a special density. Hydrogen gasoline compressed to excessive stress has yet some other density. Through checking out specific combinations, scientists slender down workable indoors systems. That is theoretical expertise grounded in physics and chemistry, set up through laboratory experiments and quantum mechanics. Maximum fashions converge on a similar photo, a rocky center one to a few instances an entire life Earth's mass. Above that, a thick mantle of immoderate pressure ice, and in all likelihood liquid water. This residue might be 1,000 to 2,000 mi thick. Above that, a hydrogen-helium environment plenty of miles deep, gradually thinning as altitude increases. This shape seems no longer something like Earth. It seems like a small Neptune with slightly extra rock and much less gasoline. If this photo is correct, the planet has no stable ground in any widespread experience. Descending through the atmosphere, you'll discover increasing strain and temperature. In the long run, the hydrogen will become so dense it behaves like liquid, deeper despite the fact that the ice mantle starts off evolved. Know how there is no sharp boundary, no area wherein you can land a spaceship. The transition from surroundings to ice takes place little by little over 700 of miles. This is expertise Neptune works. Observations advise this ocean global works in addition. Understanding Jevok knowledge, this interpretation conflicts with the dimethyl sulfide detection. Neptune does no longer produce dimethyl sulfide. Its atmosphere includes methane, ethane, acetylene, and different hydrocarbons. No sulfur, primarily based herbal molecules, have ever been detected there. If this far-flung global resembles Neptune, why does its Snoke knowledge chemistry Neptune lacks? One opportunity is a liquid water layer sandwiched between the ice mantle and the hydrogen ecosystem. At positive depth, stress and temperature have to permit liquid water to exist. This water could no longer hold in contact with space or air like Earth's oceans. It might be trapped beneath 700 of miles of hydrogen, know how it may nonetheless host lifestyles. Microbes floating on this buried ocean must produce dimethyl sulfide. The gas might bubble up via the environment, conducting altitudes in which telescopes stumble on it. Critics point out issues with this state of affairs. How should life start in a buried ocean? On the planet, life probably started in shallow swimming pools or near hydrothermal vents, places in which electricity and chemicals pay attention. A buried ocean lacks those features. Electricity could be scarce. Vitamins is probably confined. Starting lifestyles in such situations appears incredible. No knowledge as quickly as started. Perhaps through a few unknown mechanism life might spread and thrive. Every other hassle is methane. Neptune has 2% methane. This ocean global has 1%. On Neptune, methane comes from the planet's indoors, released through convection and atmospheric mixing. If this worldwide resembles Neptune, its methane might in all likelihood have the identical supply. Information ocean worldwide fashions provide an explanation for methane in a different way. They recommend organic manufacturing with methanogens growing methane from hydrogen and carbon dioxide. Each motives healthy the observations, making it difficult to distinguish among them. The controversy boils right all the way down to whether this planet has a ground and oceans or lacks every. Spectroscopy tells us what chemicals exist inside the surroundings. It does no longer right now information what lies below. We infer surface situations from atmospheric composition. Understanding inferences may be wrong. A couple of factors can match the equal facts. Breaking this degeneracy calls for added observations that probe deeper into the planet's nature. What occurs while scientists have examined the mysterious absence of a critical atmospheric thing? The concept of Hycean worlds emerged in 2021 from theoretical artwork led with the resource of researchers at Cambridge. They asked the easy question: can planets larger than Earth expertise smaller than Neptune host liquid water oceans in spite of getting hydrogen atmospheres? Traditional expertise stated no. Hydrogen atmospheres were notioned to create runaway greenhouse results, making surfaces too warm. Expertise-focused modeling located an extraordinary possibility. This is theoretical work primarily based mostly on installed climate physics. The secret's cloud formation. High in the surroundings, water vapor can condense into clouds. Those clouds replicate starlight returned into vicinity earlier than it heats the surface. If enough clouds shape, They might maintain the planet cool, however, a sturdy greenhouse effect decrease inside the surroundings. The candy spot exists while an entire life cloud cowl reaches about 50 to 70% of the planet. Too little cloud and the surface overheats. An excessive amount of cloud and starlight cannot penetrate to guide photosynthesis or warmth the water. High worlds could have floor pressures among 700, 100 and 1000 a life to me a leafy an entire life Earth's atmospheric pressure. That sounds crushing. Expertise Earth's oceans already experience such pressures only a few miles down. Lifestyles thrives inside the deep ocean in spite of pressures over 1000 a lifetime surface tiers. If existence can contend with the one's pressures in Earth's oceans, in all likelihood it could deal with them at a Hycean floor, where the pressure comes from surroundings as opposed to water intensity. Temperature is the trickier constraint. Water remains liquid between 0 and 700 degrees C at Earth's surface strain. Understanding at better pressures, water remains liquid at better temperatures. At 700 atmospheres of strain, water boils at 3 oven C rather than 700. At 700 atmospheres, the boiling factor rises to 365 degrees. This is showed via laboratory pressure temperature phase diagrams for water. The better limit comes at the important factor of water. Above 374 C and 221 atmospheres, water enters a supercrucial country in which liquid and fuel phases merge. Supercritical water has weird houses. It flows like a gas, understanding dissolves substances like a liquid. It could doubtlessly help lifestyles. Information existence as we comprehend its far predicated at the remarkable residences of liquid water. Going tremendous crucial may make habitability impossible. High-end models advise surface temperatures between 10 and 70 degrees C are feasible under the right situations. That range is well suited with existence. Earth's most up-to-date environments, like deep-sea hydrothermal vents, reach over 700 degrees C and host thriving bacterial businesses. If Hycean oceans stay cooler than that, lifestyles appears feasible. Information setting up the one's temperatures calls for specific balancing of greenhouse warming and cloud cooling. The hydrogen atmosphere serves multiple roles. It gives greenhouse warming to save you freezing. It protects from harmful space radiation. It offers metabolic gas for hydrogen-using organisms. Know how it moreover blocks ultraviolet mild that drives photosynthesis on Earth. Hycean lifestyles may additionally want to adapt to dimmer, redder mild that penetrates the environment. Purple dwarf stars emit often pink and infrared moderate besides, so this could now not be a problem. Nutrient availability poses some different challenge on the planet. Continental weathering releases minerals into rivers that go with the flow to oceans. The one's minerals offer nutrients for marine life. Hycean worlds would probably lack continents completely without weathering. How do vitamins reap the sea? Probably volcanic Hycean entire life at the seafloor releases minerals at once into water. In all likelihood the ocean is furnished from beneath with chemical materials seeping up from the rocky mantle below. One thrilling prediction is that worlds need to know how precise atmospheric signatures. Immoderate methane tears from natural manufacturing, immoderate carbon dioxide from volcanic ouching or biological respiratory, detectable water vapor, and doubtlessly biosignature gases like dimethyl sulfide or methyl chloride. This ocean worldwide suits the anticipated pattern nearly perfectly. The alignment between prediction and commentary is what excites researchers. How may thick atmospheres create strong situations? Greenhouse outcomes get a bad recognition. Climate alternate discussions attention on runaway greenhouse warming as catastrophic. Information greenhouse outcomes aren't inherently lousy. They're what make Earth habitable within the first place. Without our natural greenhouse impact, Earth's not unusual temperature is probably 8°C. The oceans may want to freeze strong. As an opportunity, greenhouse gases keep us at ease plus 15 degrees C. This is fundamental atmospheric physics, showed through decades of measurements. The mechanism is straightforward. Sunlight passes through the environment and warms the floor. The satisfactory and comfortable surface radiates electricity again as infrared mild. Greenhouse gases soak up this infrared, trapping warmth in the decreased atmosphere. The gases subsequently re-radiate the strength. Information a few goes backpedal in the direction of the ground. This creates a warming impact. More greenhouse gasoline approach greater warming. The connection isn't linear, no, how it's miles predictable. On the Earth, carbon dioxide and water vapor provide most of the greenhouse effect. Methane and nitrous oxide make a contribution, smaller quantities. Those gases work due to the fact their molecular structures take in infrared wavelength. Not all gases try this. Nitrogen and oxygen, which make up most of our ecosystem, are transparent to infrared. They do not make a contribution to greenhouse warming. Hydrogen and helium are similarly transparent. You need exclusive molecules jumbled together. This ocean global's hydrogen environment does no longer lure and lousy lot warmth without delay. Knowledge it includes approximately 1% methane and 1% carbon dioxide. That may not sound like masses, no knowledge it's far enough. Earth's environment includes satisfactory 700 factors in keeping with million carbon dioxide, that is 0.4%. This distant planet has 25 a lifetime more carbon dioxide than Earth. Methane is a good, more effective greenhouse gas than carbon dioxide. Molecule for molecule, 1% methane presents severe warming. Right here is in which hydrogen turns into important. The sheer mass of the hydrogen surroundings will increase the stress on the ground. Better strain approach denser air. Denser air holds greater warmness. It also slows the escape of infrared radiation. Photons looking to depart the planet get absorbed and remitted multiple a life-to-mere lifeine entire life earlier than eventually making it to space. Every absorption emission cycle delays warmth loss. The end result is that despite the fact that hydrogen itself does no longer trap infrared nicely, a thick hydrogen environment, however, creates amazing greenhouse warming through pressure results alone. Models information that a hydrogen environment containing 1% carbon dioxide and 1% methane can preserve ground temperatures heat enough for liquid water, even on a planet receiving less starlight than Earth. This extends the habitable area outward from the famous individual. Planets that might be too cold with Earth-like atmospheres end up heat enough with hydrogen atmospheres. It flips conventional thinking about in which to look for life. Understanding there can be entice. The greenhouse effect have to be robust, but no longer too sturdy. Venus demonstrates what occurs at the same a life an entire life. Greenhouse warming goes out of manage. Venus receives twice the daylight Earth does and has a crushing carbon dioxide surroundings. Ground temperatures reap 470 degrees C, warm sufficient to melt lead. The greenhouse impact ran away. All water evaporated, growing greater greenhouse gas, growing extra warming, growing greater evaporation. A high-quality Comets loop with no braking mechanism. This ocean global sits right on the edge. Computer fashions display that small changes in atmospheric composition or cloud cover could push it into runaway greenhouse territory. If clouds fail to shape, floor temperatures spike. Water evaporates, developing greater greenhouse warming. As soon as started out, the system is probably irreversible. As an opportunity, if clouds end up too thick, they block too much starlight. Ground temperatures drop, water freezes, frozen surfaces reflect extra light, developing extra cooling. Every other runaway method, information in the opposite direction. The truth that this planet seemingly keeps strong situations, expertise, a balancing mechanism. Perhaps biological procedures assist stabilize weather. On this planet, phytoplankton produce dimethyl sulfide which seeds clouds. More warming technique, more phytoplankton. More phytoplankton technique, more dimethyl sulfide. Extra dimethyl sulfide mana greater clouds. More clouds endorse more cooling. This poor comments might prevent runaway warming. The same mechanism can also lead to artwork on this ocean international. If so, lifestyles may now not in reality exist there. Lifestyles might actively alter the planet's climate, making it habitable. Why does the absence of ammonia split clinical opinion? Ammonia need to be there. Multiple models assume it. Yet observations understanding display no hint. This absence has ended up one of the most debated factors of this planet's environment. Ammonia is nitrogen and hydrogen combined. Components written as one nitrogen atom bonded to 3 hydrogen atoms. In a hydrogen-wealthy environment receiving strength from starlight or lightning, ammonia formation is expected. This is showed chemistry discovered in laboratory experiments and in fuel huge atmospheres in our Sun device. Jupiter has ammonia. So does Saturn, Uranus, and Neptune. Anywhere you discover hydrogen and nitrogen together with enough strength to power reactions, ammonia seems. Spectroscopic observations of these planets understanding knowledge, strong ammonia absorption features. Nobody questions whether ammonia is there. The query is why it's far missing from this ocean global when it need to be present. One clarification invokes natural intake. Some microorganism on Earth metabolize ammonia as an strength source. Nitrifying bacteria convert ammonia to nitrite, then nitrate. They gain electricity from those reactions. In an ocean complete of such microorganism, ammonia may be eliminated from the surroundings as fast because it forms. The ocean acts as a sink. Atmospheric ammonia dissolves into water. Microorganisms eat it. More atmospheric ammonia dissolves to update what end up ate up. An equilibrium establishes in which ammonia concentrations lie close to zero. This clarification suits the sea worldwide speculation nicely. It calls for existence. Information life is what the Dimethyl Sulfide sign understanding. Besides, the two pieces of evidence manual every other. Organic metabolism explains both the presence of dimethyl sulfide and the absence of ammonia. It creates a self-everyday picture. Understanding, but it calls for assuming existence exists. That's what scientists are trying to show. Spherical reasoning will become a risk. The possibility explanation invokes chemistry without biology. If the ground is molten rock, nitrogen dissolves into the magma. Experimental studies of volcanic systems know how that at excessive temperatures and pressures, nitrogen partitions into softened ranges instead of staying inside the gasoline phase. A magma ocean could suck nitrogen out of the atmosphere. Without atmospheric nitrogen, ammonia can't shape. The absence of ammonia becomes proof for a magma ocean rather than a water ocean. This explanation fits the magma ocean hypothesis well. It requires no lifestyles. It explains the lacking ammonia via honest chemistry. Understanding it struggles to provide an explanation for the dimethyl sulfide. As discussed earlier, magma ocean models can produce small quantities of dimethyl sulfide through abiotic chemistry. Whether they could produce enough remains questionable. The magma ocean hypothesis explains one thriller at the equal of life. Time is struggling with every different. There is a third opportunity rarely mentioned. Possibly the spectroscopic observations truly not noted the ammonia. Ammonia has absorption capabilities at precise wavelengths. If those wavelengths were not determined, or if noise obscured the sign, ammonia can be present but undetected. Information. The James Webb Area Telescope discovered multiple wavelength tiers. The gadgets have sufficient sensitivity to find out ammonia at anticipated concentrations. More than one studies groups analyze the data independently, or reach the identical conclusion: no ammonia. The lacking ammonia forces scientists to select amongst competing situations. Both existence consumes it or magma absorbs it, or a few 1-3 unknown approach gets rid of it. Every desire leads down an awesome direction for records this global. Ocean global with existence, magma ocean without lifestyles, or something absolutely sudden. The scientific network remains split. A few researchers strongly decide upon the organic clarification. Others lean toward magma oceans. A third company argues the information stays too ambiguous to pick. What they all agree on is that greater observations are desperately wanted to interrupt the impasse. Trust an ocean in which each drop of water consists of 1,000 instances an entire life, greater microbes than Earth's maximum effective seas. That's what the numbers demand. The dimethyl sulfide concentrations located require surprising quantities of organic a lifetime. In the world, phytoplankton waft in the sunlit groundwaters approximately the top 700 feet wherein light penetrates. Underneath that, darkness reigns, photosynthesis stops. On this ocean global, the same depth restrict could have a look at unless something adjustments the guidelines. One opportunity is definitely density. Earth's oceans consist of greater or much less 1 million bacterial cells constant with mil of seawater. That looks like 700 until you take into account that fertile soil includes 1 billion cells in step with gram. Ocean water is pretty sparse in microbial existence as compared to other environments. Probable this far-off ocean is more like fertile soil, dense bacterial mats floating in the water column, thick biofilms coating every available ground, Microbial density 1,000 lifetimes better than Earth's oceans. This is speculation, know how math requires it. Some different opportunity consists of particular organisms completely. In the world, dimethyl sulfide comes regularly from eukaryotic phytoplankton, organisms with complex cells containing nuclei and organelles. Those advanced, noticeably overdue in Earth's records, approximately 2 billion years within the past. In advance than that, much less tough microorganism ruled. In all likelihood, this ocean international hosts microorganism that produce dimethyl sulfide through awesome metabolic pathways. Microorganism can evolve fast, adapting to nearby conditions within 700s of generations. An ocean complete of dimethyl sulfide producing bacteria need to generate the discovered concentrations. The hydrogen environment opens particular metabolic opportunities. Some Earth bacteria known as methanogens combine hydrogen fuel with carbon dioxide to provide methane. They advantage electricity from this response. It really works well in environments without oxygen. Possibly similar organisms on this ocean international combine hydrogen with sulfur compounds to supply dimethyl sulfide at once. This may be more green than Earth's pathway, where dimethyl sulfide forms as a byproduct in place of a number one metabolic product. Temperature topics 2. Hotter water manner faster metabolism. Chemical reactions greater or much less double in pace for each 10 degrees C increase in temperature. If this ocean's floor averages 30 degrees C in evaluation to Earth's 4 degrees, reactions preserve about 8 a lifetime faster. 8 a life time faster metabolism technique 8 instances an entire life extra dimethyl sulfide manufacturing in keeping with cellular. Multiply that by means of the usage of higher cell density, and also you start carrying out the specified manufacturing costs. There is also the question of evolutionary pressure. On Earth, phytoplankton produced dimethyl sulfonopropionate to modify salt stability. The dimethyl sulfide is unintentional. Information: what if organisms in this worldwide use dimethyl sulfide for communique? Bacteria on the planet use chemical indicators to coordinate conduct, a procedure called quorum sensing. A lifetime sufficient bacteria accumulate in a single region. Their chemical signals reach threshold concentrations that trigger collective responses. In all likelihood, dimethyl sulfide serves this function there, with organisms intentionally producing it in big quantities. Electricity availability drives natural productiveness on Earth. Photosynthesis captures a life time and converts it to chemical strength that powers the food chain. This ocean worldwide receives comparable amounts of starlight as Earth. The red dwarf big name emits more pink and infrared moderate in assessment to our sun's broader spectrum. Understand ingevic knowledge a few Earth organisms photosynth good-sized using red slight correctly. Red bacteria and a few cyanobacteria thrive in red-dominated environments. Existence there might have tailored in addition. Nutrient availability is further essential on the Earth. Upwelling brings nutrients from deep water to the surface, fueling productive regions much like the California coast and the waters round Antarctica. Without continents to create coastal upwelling, this ocean global might rely on one of a type mechanisms. Perhaps volcanic life time on the seafloor releases vitamins immediately into the water column. In all likelihood, sturdy tidal forces from the nearby famous person create mixing that brings deep vitamins to the floor. Both manner, excessive productivity calls for excessive nutrient supply. Information may want to lifestyles even continue to exist. The temperature swings this planet research. Lifestyles on the planet survives excellent extremes. Bacteria thrive in boiling heat springs at Yellowstone, in which water reaches 90 degrees C. Exclusive organisms live to tell the tale in Antarctic ice at 40. Tardigrades, microscopic animals called water bears, can bear temperatures from near absolute zero to 750 C. Existence is tougher than most people realize. Those extremes are showed through direct assertion and laboratory trying out. Expertise this ocean global could possibly push even past Earth's extremes. Weather fashions understanding display that relying on atmospheric situations, floor temperatures must range from 10 degrees C to over 70 degrees C. The elliptical orbit reasons variations for the duration of each 33-day 12 months. At closest technique to the celeb, temperatures spike. At farthest distance, they drop. The distinction might also exceed 20 degrees C between orbital extremes. Any lifestyles there ought to control those swings or discover procedures to keep away from them. Earth organisms use severer techniques for temperature tolerance. A few input dormancy a life, time of bad situations. Bacterial spores can live to tell the story for 700 of years in suspended animation, anticipating conditions to decorate. While in entire life temperatures end up favorable yet again, they reactivate and resume growth. Possibly organisms on this ocean worldwide spirit in the course of temperature extremes, then bloom during mild periods. This will create cycles of natural hobbies synchronized with the orbit. One-of-a-kind organisms use biochemical versions. Proteins fold into specific shapes to perform their capabilities. Temperature affects protein stability. Too warm and protein spread dropping characteristic. Too bloodless and enzymes sluggish down. Information thermophilic organisms, warm temperature loving microorganism, produce proteins with more chemical bonds that stabilize structure at immoderate temperatures. Psychrophilic organisms, bloodless loving bacteria, use flexible proteins that stay energetic although bloodless. Existence on this ocean world may also combine each strategies, producing proteins sturdy at some stage in big temperature degrees. The sea itself offers buffering. Water has immoderate warmth capacity. That means it takes quite some power to change its temperature. Huge are our bodies of water heat slowly and cool slowly. Even supposing air temperatures swing wildly, ocean temperatures stay greater strong. Earth's oceans acknowledge each day temperature variations of simply 1 or 2 degrees on the ground. Irrespective of air temperature swings of 10 or 20 degrees, an ocean in this far-flung international should in addition buffer temperature changes, smoothing out the orbital variations. Intensity offers another secure haven. On the planet, surface waters variety in temperature with seasons and climate. Deeper waters remain solid 12 months spherical. Under approximately 700 toes, ocean temperature slightly changes. It stays around 4°C in maximum locations irrespective of what takes vicinity at the ground. Existence may also need to retreat to solid deep water during temperature extremes, then upward push to the green floor layer in the course of favorable intervals. Vertical migration is not unusual in Earth's oceans. Many organisms descend all through day and rise at a lifetime. No knowledge intense temperatures create some other trouble. Chemical response quotes exchange with temperature. Now not just natural reactions, understanding all chemistry. At higher temperatures, dimethyl sulfide breaks down faster. At decreased temperatures, it persists longer. The various life time at some stage in the orbital cycle complicates atmospheric modeling. Scientists need to account for a lifetime set-up chemistry wherein response prices shift as the planet movements along its elliptical direction. There may be evidence that life adapts to cyclic extremes higher than consistent extremes. Organisms can prepare for predictable changes. Earlier than wintry weather arrives, bushes flow into nutrients into their roots and shed leaves. In advance than dry season comes, a few fish bury themselves in mud and enter hibernation. The secret is predictability. If the 33-day cycle repeats reliably, lifestyles must evolve responses precipitated through environmental cues like converting moderate intensity or temperature. No knowledge temperature isn't always the only venture this planet offers. What approximately the dayite problem? Well, in entire life a planet orbits very near its well-known person, gravitational forces reshape the entirety. The well-known man or woman pulls harder on the near facet than the some distance aspect. This distinction in pull, known as tidal pressure, creates friction in the planet. Over 700 of years, this friction slows the planet's rotation. In the end, the planet rotates at exactly the same speed it orbits. One side absolutely faces the big name. The alternative component faces everlasting darkness. This is showed physics determined throughout our sun machine. Our moon is tidally locked to Earth. The equal facet continuously faces us. We by no means see the some distant side from Earth without spacecraft. Mercury is kind of tidally locked to the solar, rotating 3 a lifetime Alephian entire life for each orbits. Maximum planets orbiting near pink dwarfs are predicted to be absolutely tidally locked. The entire life scale relies upon on distance, planet mass, and inner shape. For this ocean worldwide orbiting really 13 million m from its well-known person, tidal locking almost virtually took place within the first few 700 million years. This is theoretical, no, how strongly supported through calculations. Tidal locking creates dramatic consequences. The day side gets constant starlight, never experiencing a lifetime. Temperatures there remain immoderate continuously. The alive to me an entire life facet gets no direct starlight ever, remaining frozen. Between those extremes lies a twilight quarter, a ring across the planet where the big name hangs on the horizon. This terminator vicinity studies neither complete day nor full night. It is probably the simplest place with moderate temperatures. On the planet, daylight cycles power weather, ocean currents, and biological rhythms. Vegetation photosynth massive at some point of day and respire at a life to me an entire life a lifetime. Animals coordinate hobby to circadian rhythms. A tidally locked international lacks those cycles. Life there could want to comply to everyday situations, whether constantly mild or constantly darkish. The twilight place could probably host the maximum numerous existence, profiting from every illumination and moderate temperatures. Understand Injavuk knowledge atmospheric motion changes everything. A thick atmosphere transports warmth from dayside to a life to me an entire life factor. On this planet, atmospheric motion creates wind patterns, jetstreams and weather systems. On a tightly locked planet, go with the flow could be some distance extra excessive. Air heated at the day facet ought to upward push and drift towards the night a lifetime aspect. Cold air at the a lifetime facet might sink and float back closer to the day side. The result is a plant-wide go with the flow cell with winds probable accomplishing 700 of miles hour. Laptop fashions understanding knowledge that a thick hydrogen surroundings ought to shipping enough warmth to prevent the a life time aspect from freezing truly. The day aspect would probably acquire 700 C or extra. Information a life to me an entire life a life. Time facet may stay above freezing because of warmness delivery. This creates livable situations during an awful lot large surface vicinity than the twilight zone by myself. The ocean itself ought to flow into, driven via temperature differences and wind pressure. Warmness water might go with the flow from dayside towards night a life an entire life factor. Bloodless water should return in deep currents. Information, constant illumination at the dayside creates photochemical disturbing situations. Day a life an entire life drives chemical reactions in the atmosphere. On this planet, these reactions reset each a lifetime a life. Time the sun goes down. Reactive molecules produced all through the day get destroyed at a life to me an entire life, preserving balance. On a tidally locked planet, the dayside by no means receives a damage. Photochemistry runs constantly. This could damage biosignature gases earlier than they unfold to the a life to me an entire life element, or it can create one of kind chemistry impossible on this planet. The a lifetime facet offers different disturbing conditions. Without a daylight, photosynthesis can't arise there. Any existence at the a lifetime time aspect need to rely upon chemical energy in preference to moderate. On the Earth, deep sea ecosystems near hydrothermal vent screen that existence can thrive without daylight. Chemosynthetic bacteria extract energy from hydrogen sulfide and other chemical substances. A whole food chain exists impartial of photosynthesis. Probable similar ecosystems cover this planet's a life to me an entire life aspect, fed by way of chemical materials upwelling from beneath. Tidal locking additionally influences tidal forces themselves. With the planet constantly displaying the equal face to the megastar, tidal boges remain consistent in region. The sea may want to have a everlasting excessive tide at the day aspect, and a life to me an entire life a lifetime facet, with eternal low tide at the poles. This creates standing wave styles unlike something in the world. What if this complete biological interpretation is wrong? Scientists do now not anticipate biology is the handiest clarification. They check alternatives. Over the last decade, a couple of research organizations have investigated whether or no longer dimethyl sulfide can form without life. The effects complicate the picture. In 2024, One organization posted experiments displaying that ultraviolet light can force reactions among methane and hydrogen sulfide that produce small amounts of dimethyl sulfide. That is, showed experimental records replicated beneath managed situations. The experiments worked like this. Researchers crammed a chamber with fuel combinations, just like what might possibly exist on Hycean planets. Hydrogen, methane, carbon dioxide, and hydrogen sulfide in diverse ratios. They sealed the chamber and exposed it to ultraviolet lamps mimicking starlight. Over days, or perhaps weeks, they sampled the gas and analyzed its composition, the use of mass spectrometry. The results showed formation of several herbal sulfur compounds, which include trace quantities of dimethyl sulfide. The mechanism entails free radicals, molecular fragments with unpaired electrons. Ultraviolet mild breaks apart methane, growing methyl radicals. Those radicals can then react with hydrogen sulfide, which additionally breaks apart below UV moderate. Through a chain of reactions, methyl radicals combine with sulfur to shape dimethyl sulfide. The chemistry is complex, concerning multiple intermediate steps. Expertise, it really works. You can make dimethyl sulfide without biology. Expertise, the yields were tiny. The experiments produced dimethyl sulfide at concentrations measured in components in line with billion. To attain the elements constant with million degrees discovered on this ocean global requires yields, lots of a life, time better. The researchers said this dilemma. They recommended that probable non-forestal volcanic outgassing of hydrogen sulfide blended with excessive photochemistry might possibly enhance manufacturing. Expertise, even beneficent assumptions fell brief of explaining observations. Another experiment explored unique pathways. Scientists simulated situations in molecular clouds, the cold, dense areas of area wherein stars shape. They mixed simple molecules on ice grains and uncovered them to radiation. Below the one's intense conditions, they created various natural compounds in conjunction with dimethyl sulfide. This confirmed that dimethyl sulfide can form in space in advance than planets even exist. Comets and asteroids could possibly supply dimethyl sulfide to planetary atmospheres inside the course of effects. Expertise transport through comets faces problems. Any dimethyl sulfide brought from area could be destroyed speedy by way of using atmospheric chemistry. To hold the discovered concentrations calls for continuous replenishment. A planet would need constant bombardment via dimethyl sulfide-rich comets. We see no proof for such bombardment. Crater counts on planets and moons offer clues about impact costs. This ocean worldwide, primarily based mostly on its age and orbit, want to now not experience heavy bombardment. A third set of experiments examined excessive temperature chemistry. A lifetime hydrogen sulfide reacts with organic molecules at temperatures above 500 degrees C. Various sulfur compounds shape. Volcanic vents at the seafloor may additionally provide such situations. Heat fluids rich in hydrogen sulfide mixing with organic molecules from organic or abiotic resources may want to generate dimethyl sulfide. This pathway does not require existence at once, though it requires natural precursors that lifestyles produces. The venture is scale. Those kinds of abiotic pathways work in precept. They produce measurable dimethyl sulfide in laboratory settings. Information scaling them as much as planetary degrees calls for notable situations. Regular intense UV radiation, large volcanic outgassing fees, uncommon atmospheric compositions that maximize manufacturing even as minimizing destruction. The mixture of all factors desired concurrently appears not going, though not likely isn't always no longer viable. One researcher put it bluntly, "Sure, we can make dimethyl sulfide without lifestyles. No knowledge making sufficient dimethyl sulfide to offer an explanation for observations without lifestyles requires such a lot of unique situations that invoking biology will become less difficult. Biology is green at generating precise molecules. Abiotic chemistry has an inclination to offer the whole lot straight away in small amounts. The specificity and abundance of dimethyl sulfide factors in the direction of organic manufacturing. Information what about fake signals from vicinity particles? Scientists made an unexpected discovery. They detected dimethyl sulfide on a comet. The comet named 67P Churyum of Gerasimenko changed into visited by way of the U-Area I's Rosetta probe. Gadgets aboard, Rosetta sampled the fuel and dirt streaming from the comet's floor because it warmed close to the Sunday. Among dozens of detected molecules, dimethyl sulfide appeared. This confirmed that dimethyl sulfide exists in cometary ice created via abiotic approaches before the comet shaped. The detection challenged assumptions about biosignatures. If comets include dimethyl sulfide, then locating it on a planet won't imply lifestyles. Perhaps influences added the molecule. Perhaps outgassing from deep within the planet releases cometary material that accreted in the course of formation. Each situation should provide a reason behind atmospheric dimethyl sulfide without biology. This opportunity is supported through direct comet observations. No longer speculation, understanding portions matter. The dimethyl sulfide detected at the comet existed at very low abundance, components steady with million within the comet's ice. Whilst that ice sublimates into gas, it dilutes even in addition. Handing over sufficient dimethyl sulfide to offer a reason for atmospheric concentrations of 10 factors, in keeping with million, could require enormous numbers of effects. Scientists calculated the preferred effect charge. The numbers have been absurd. You may want influences dumping 700 of heaps of cometary cloth into the environment every day. Such excessive effect charges might expertise other consequences. Effects supply greater than honestly dimethyl sulfide. Comets comprise water, carbon monoxide, ammonia, methanol, formaldehyde, and dozens of different molecules. If effects were turning in dimethyl sulfide, they have to be handing over these types of distinctive molecules too. But atmospheric observations do no longer acknowledge uncommon abundances of various cometary volatiles. Carbon monoxide appears absent or very low. Ammonia is missing. The chemical signature does no longer in shape, non-stop cometary transport. There may be some other trouble, impact speeds. Well, in entire life a comet hits a planet, from 10s to 700 of kilometers. Those hypervelocity impacts launch a 40 AF 5C6 500 63 power. Temperatures at effect sites attain 700 of levels. Maximum molecules get destroyed. Complex natural molecules like dimethyl sulfide might break apart into much less difficult fragments. Only the most strong molecules continue to exist. Dimethyl sulfide isn't specially robust. It wants to be destroyed, not delivered intact. A few impacts get up at lower velocities. If the planet captures a comet gravitationally and the comet spirals inward slowly, it would hit at just a few kilometers. Those slight influences may additionally maintain molecules higher. Understanding mild impacts are uncommon. Most comets both emit absolutely or hit hard. The risk of maintaining prevent moderate influences over 700 of years appears vanishingly small. There's one situation in which cometary delivery may work. If the planet fashioned in an area wealthy with cometary material and captured large amounts during formation, that fabric might be stored within the planet's interior. A lifetime volcanic hobby or convection might convey this material to the floor, freeing historical cometary volatiles into the environment. This would no longer require ongoing impacts, simply launch of primordial material. Expertise this state of affairs calls for the dimethyl sulfide to live to inform the story in the planet for billions of years. Planetary interiors gain temperatures of masses of stages. Pressures exceed heaps and 700s of atmospheres. Most molecules wreck down under such situations. Best the most chemically stable compounds live on. Dimethyl sulfide might almost truly be destroyed at some point of garage. Water survives because its miles rather robust. Smooth gases like hydrogen, methane, and carbon dioxide stay to inform the tale. Complicated organic sulfur compounds do no longer. The comet connection remains a cautionary story in vicinity of a real alternative. It reminds scientists that biosignature molecules will have non-biological assets. It forces extra careful interpretation of observations. Know how it does now not supply an explanation for the particular case of this ocean worldwide. The dimethyl sulfide concentrations are too excessive. The lack of different cometary signatures is just too complete. The chemical surroundings is simply too damaging to hold added molecules a lifetime. What about volcanic resources that mimic existence's chemistry? Volcanoes on Earth spew sulfur in lots of paperwork. Sulfur dioxide dominates volcanic emissions. launched a lifetime as magma rises and pressure drops. Hydrogen sulfide follows the rotten egg scent related to volcanic areas. Sulfur's chemistry is complex with multiple oxidation states permitting it to bond with nearly something. In volcanic environments, sulfur reacts with carbon, hydrogen, and oxygen to form dozens of different compounds. That is well-established geochemistry discovered at Volcanic Net websites global. Volcanic tactics on this ocean worldwide create dimethyl sulfide. One pathway includes methane reacting with sulfur-containing volcanic gases. Methane is enough inside the atmosphere, confirmed at 1% interest. If volcanic vents release hydrogen sulfide, and that hydrogen sulfide encounters methane below the proper conditions, reactions have to produce organic sulfur compounds. Excessive temperatures may pick out one in all-a-kind merchandise than low temperatures. The right temperature variety could possibly select dimethyl sulfide formation. Laboratory experiments explored this opportunity. Researchers combined methane and hydrogen sulfide and heated them to various temperatures. A 345444846B9593F4G numerous herbal sulfur compounds shaped carbon delphide appeared. Carbonyl sulfide appeared, methyl mercaptan regarded. Dimethyl sulfide seemed no how only in hint amounts. The product distribution became messy, producing many molecules concurrently. This is conventional of abiotic chemistry. Existence produces specific molecules effectively. Abiotic techniques produce the entirety right now inefficiently. The volcanic pathway faces quantitative issues. To preserve 10 components in step with million dimethyl sulfide within the ecosystem calls for non-stop manufacturing matching destruction fees. Scientists calculated the important volcanic outgassing costs. They predicted that hydrogen sulfide emissions could want to exceed Earth's entire volcanic output through factors of loads or masses. This ocean global could want to be one of the most volcanically lively bodies within the diagnosed universe. Well, an entire life no longer not possible. It appears not going. There may be additionally the methane problem. Methane itself requires clarification. In the world, maximum atmospheric methane comes from biology produced through methanogenic microorganism or released during decomposition of organic depend. Some comes from geological assets, like serpentinization, in which water reacts with shore rocks to offer hydrogen and methane. Understanding geovet knowledge, these geological belongings produce noticeably small amounts. The 1 cent methane on this ocean global exceeds what abiotic strategies normally generate. If volcanoes produce the methane, they have to also produce dimethyl sulfide through the identical tactics. That creates a self-consistent abiotic scenario. Know how it calls for pretty energetic volcanism and unique chemical conditions that maximize organic molecule production. Models conflict to gain both requirements simultaneously. Each volcanism is just too prone to deliver enough gasoline, or temperatures are too high to permit natural molecules to live to tell the tale. Each different volcanic pathway includes intermediate water chemistry. Volcanic gases dissolve in ocean water. The dissolved gases then react with every different in answer in place of in the atmosphere. Aqueous chemistry lets in unique reaction pathways. A few reactions that don't work in gas segment continue efficiently in water. Possibly dissolved hydrogen sulfide and dissolved organic molecules integrate to form dimethyl sulfide within the ocean. The dimethyl sulfide then evaporates into the atmosphere. This aqueous pathway faces its very own disturbing situations. Ocean chemistry is buffered by means of way of dissolved minerals. Seawater on this planet has a pH spherical 8, barely alkaline. This pH variety strongly impacts what reactions occur. Dimethyl sulfide formation normally favors acidic or neutral conditions, now not alkaline. Know how we do not realize the pH of this ocean international's water. If volcanic a lifetime acidifies the sea, that would desire dimethyl sulfide formation. Information acidic oceans may dissolve carbonate minerals and snoke knowledge brilliant atmospheric carbon dioxide stages. The observations do now not genuinely assist intense pH. The fact is that scientists have no longer knowledge determined a volcanic pathway that clearly explains the observations without invoking first-rate conditions. Volcanic assets might probably make a contribution a few dimethyl sulfide. They may provide a reason behind a part of the sign. Information explaining the entire found attention requires each extreme volcanism or noticeably precise chemistry or each. As factors move, biology stays much less hard. What if the well-known person itself makes this planet uninhabitable? Red dwarf stars are violent. They erupt with massive flares, freeing strength identical to billions of nuclear bombs. Those stellar flares blast nearby planets with X-rays, ultraviolet radiation, and streams of charged particles. The flares appear often, a lifetime more than an entire life, according to Day, in some unspecified Alephin entire life of active period. That is confirmed via observations of Lot 700 of pink dwarfs. We've watched them flare. We're given measured the energy. The hazard is real. Why do crimson dwarfs flare lots? The solution lies in expertise. They generate magnetic fields. Stars create magnetic fields through dynamo methods, wherein flowing electrically conductive plasma generates electric-powered currents that produce magnetic fields. On our Sun, the dynamo operates in a shell near the ground. On red dwarfs, the dynamo operates at a fuse stage in the whole massive name. Due to the truth, they will be virtually convective. Warm plasma from the center rises to the floor. Cool plasma from the floor sinks to the center. This creates effective tangled magnetic fields. The one's magnetic fields store big power. A lifetime vicinity lines become twisted and burdened. After they launch that stored power, you get a flare. Material heated to Lot 700 and 700 of degrees erupts from the celebrity's floor. Radiation in the course of the electromagnetic spectrum floods outward. For a planet orbiting nearby, this is catastrophic. The radiation hits in minutes. There may be no warning, no a lifetime to take secure haven. What does this radiation do to atmospheres? Ultraviolet, mild, and X-rays slam into the upper environment, ionizing molecules and atoms. Ionization strips electrons from atoms, growing charged particles. Those charged particles are reactive. They tear apart molecules. Complicated natural molecules get destroyed. On this planet, our magnetic area and thick environment shield us from sun flares. Mars lacks a sturdy magnetic discipline and has a skinny surroundings, in part because of the fact solar winds stripped it away over billions of years. This ocean global orbits a good deal closer to its celebrity than Mars. Orbits the Sunday. The flares hit greater hard. The radiation is more extreme. If the planet lacks a magnetic subject, the surroundings is uncovered right now. Scientists estimate that over billions of years, a pink dwarf ought to strip away several Earth 700 of environment from a close-by planet. That this ocean global retains its atmosphere, Snoke knowledge either it has a magnetic area or its gravity is powerful enough to keep onto surroundings despite losses, or the superstar is a whole lot much less energetic than regular pink dwarfs. Magnetic fields rely on planetary interiors. Earth has a magnetic concern due to the fact its liquid iron middle convex, developing a dynamo similar to stellar dynamos. Rocky planets with solidified cores lose their magnetic fields. This ocean international is large sufficient that it would keep internal heat from formation. If it has a liquid metallic core, it can generate a magnetic field. No observations straight away confirm this. We can't degree magnetic fields on such far-off planets, but we are able to first-rate infer their presence or absence from indirect proof. Despite the fact that a magnetic discipline exists, flares nevertheless pose issues for life. The radiation won't strip the surroundings without a doubt. Know how it penetrates deep enough to affect surface conditions. On the planet, the ozone layer absorbs harmful UV radiation. Oxygen within the environment creates ozone. This ocean worldwide has minimum oxygen. Without ozone, UV radiation reaches the ground unimpeded. Organisms there may need safety mechanisms like thick cellular partitions, radiation-resistant proteins, or absolutely residing underwater in which water absorbs radiation. Flare frequency subjects. If flares seem every day, life have to deal with normal bombardment. If flares appear every hour, there are prolonged recuperation periods. Observations of this unique purple dwarf expertise, it's far quite antique at 2.44 billion years. Antique red dwarfs tend to be calmer than young ones. Stellar hobby declines a lifetime as stars spin down and magnetic fields weaken. Possibly this celeb has mellowed enough that its flares now not threaten planetary atmospheres severely. No, how even quiet pink dwarfs flare a lifetime. One large flare may also need to quickly break BIOS signature gases inside the environment. If dimethyl sulfide gets obliterated during a flare, observations in a while might display decreased concentrations. Multiple observations spread for the duration of months could display whether concentrations vary with stellar hobby. So far, the records comes from certainly announcement windows. Greater observations could probably expertise temporal variations that know how flare impacts. What approximately the gentler expertise persistent stellar wind? All stars emit stellar wind, streams of charged debris flowing outward. Our solar produces solar wind that travels approximately 1 million miles an hour. This wind consists of away mass. Over the solar's lifetime, it has misplaced a tiny fraction of its standard mass through this approach. The wind additionally includes magnetic discipline traces that have interaction with planetary magnetic fields. Earth's magnetosphere deflects maximum sun wind round us. Debris that penetrate create auroras at the poles. This is well understood location physics, confirmed through the usage of decades of spacecraft measurements. Purple dwarf stars emit weaker stellar winds than the Sun through general mass loss. Expertise their planet's orbit so close to that wind density will become essential. Consider status in a slight breeze in preference to status in that identical breeze at the equal a lifetime as pressed in competition to the fan generating it. This ocean international sits 13 million miles from its celebrity. Earth sits 93 million miles from the Sunday. The planet orbits 7 instances an entire life nearer relative to stellar period. At that distance, stellar wind density is notably higher. Stellar wind erodes atmospheres through numerous mechanisms. First, momentum transfer. Fast-moving particles collide with atmospheric atoms and molecules. A lifetime the one's collisions impart sufficient energy for atmospheric debris to break out gravity. This is known as sputtering. One at a time, atoms get knocked into space. Over 700 of years, sputtering gets rid of enormous atmospheric mass, 20 phi alternate. Stellar wind consists of ionized particles, usually protons. Whilst those ions stumble upon unbiased atoms in an ecosystem, they may be capable of steal electrons. The newly ionized atmospheric atoms respond to magnetic fields. They get swept up via using the stellar wind and overexcited. This approach is particularly green at disposing of hydrogen and helium, which might be light and results easily ionized. 0.33 atmospheric heating. Stellar wind deposits strength into the higher environment. The surroundings heats up. Warm atmospheric particles pass faster. Some reach getaway pace and go with the flow away. This thermal getaway mechanism is first class for mild elements. Hydrogen escapes quickest. Then helium. Heavier elements like nitrogen, oxygen, and carbon escape more slowly. No knowledge, nevertheless get away. Mars offers a cautionary story. Mars once had a thicker environment, glaring from historic river valleys and lake beds. Over billions of years, sun wind stripped most of it away. Mars misplaced its magnetic field early in its history. A lifetime its center solidified. Without magnetic safety, the atmosphere became inclined. In recent entire life, Mars has an awful lot much less than 1% the atmospheric stress of Earth. The planet dried out and froze. That is showed through rover missions and orbiting spacecraft that measured atmospheric loss expenses at once. Should the equal destiny befall this ocean global, the hydrogen environment might probably clearly help defend toward loss. Hydrogen is the lightest element. It occupies the uppermost atmospheric layers. Stellar wind interacts in standard with this hydrogen, stripping it away, leaving heavier molecules deeper inside the surroundings untouched. The big hydrogen envelope acts as a sacrificial defend. As long as the planet replenishes hydrogen from underneath, it can keep surroundings indefinitely. Information in which does alternative hydrogen come from? If the planet has a hydrogen rich indoors, convection and outgassing have to launch hydrogen continuously. As an opportunity, if the planet includes water, that water may want to damage down into hydrogen and oxygen. The hydrogen escapes. The oxygen reacts with floor materials or receives protected into molecules. This may slowly dry out the planet over billions of years. Venus demonstrates this way. Venus lost an ocean's worth of water via hydrogen getaway. The planet baked dry underneath a runaway greenhouse. Scientists estimate atmospheric loss charges using models that enter stellar wind houses, planetary gravity, magnetic challenge strength, if any, and atmospheric composition. For this ocean global, estimates range broadly relying on assumptions. Constructive fashions advocate atmospheric loss charges low sufficient that the planet continues surroundings for billions of years. Pessimistic fashions suggest rapid loss that would strip the ecosystem within masses of tens of 700 of years. The truth that environment stays after 2 billion years presents a constraint. Loss quotes cannot be as high as the pessimistic fashions are anticipating. Expertise past that conclusion remains unsure. What approximately the crazy elliptical orbit? Consider the elliptical orbit eccentricity of 0.09 technique. The planet's distance from its celebrity varies via the use of 12% between closest and farthest approach. That interprets to 43% variation in received starlight. Recall if Earth seasons labored that manner, as opposed to mild temperature modifications driven with the useful resource of axial tilt, we'd revel in violent swings every few months. That is, showed orbital mechanics calculated right away from unique timing measurements of transits. The orbital period is 33 days. That means the planet goes from most starlight to minimal starlight in about 16 days, then lower back to maximum in some other 16 days. For life, this creates a punishing rhythm in reality as organisms adapt to excessive temperatures and excessive mild levels. Conditions reverse, temperatures drop, slight dims. Then, earlier than variant completes, conditions opposite once more. It is like seeking to acclimate to summertime and wintry climate simultaneously. On this planet, seasonal modifications show up slowly enough that lifestyles adapts. Timber experience day length changes months earlier than wintry climate and prepare by way of the use of moving vitamins and losing leaves. Animals constructing up fat reserves or migrate to hotter climates. Those adaptations aren't work due to the reality season's final months and repeat predictably each 12-month 700. Expertise 3-day cycles are quicker than maximum organic variations. A tree cannot develop leaves, then shed them, then grow them once more every few weeks. Microbial life may address this higher than complex organisms. Microorganisms reproduce speedy. Generation a lifetime can be hours to days. In 33 days, bacteria undergo dozens or 700 of generations. That allows speedy evolution. Bacterial populations have to adapt to converting conditions via natural choice, working in actual a lifetime. Useful mutations unfold through the population interior one orbital duration. Complex organisms with a lifetime of years cannot adapt this brief. The temperature swings affect ocean glide. Warmer water expands, cooler water contracts. Because the planet actions through its orbit, the sea actually swells and shrinks. This creates tides destroy unfastened gravitational tides. These thermal tides could power currents, blending ground and deep water. The mixing can also assist distribute vitamins, reaping advantages marine existence, or it disrupt stable water layers, harming organisms tailor-made to specific depths. Atmospheric chemistry adjustments with temperature too. Chemical reaction fees double each 10 degrees. As a rough rule, if ground temperatures range through 20 degrees over the orbital cycle, reaction expenses range via the use of a detail of 4. Dimethyl sulfide destruction happens for a lifetime quicker at orbital closest approach than at farthest approach. Manufacturing prices moreover vary in the occasion that they depend on temperature-sensitive organic approaches. The give-up end result is that atmospheric concentrations might also oscillate with the orbit. Internet observations captured snapshots at particular moments during the orbit. The records represents a few thin conditions existed while the planet befell to transit its well-known individual. If concentrations range appreciably, one of a type observations would possibly snoke knowledge one-of-a-kind dimethyl sulfide levels. Comparing more than one observations could reveal whether concentrations are stable or variable. To date, observations understanding consistent outcomes. Information to statistics factors are not sufficient to rule out variability. The elliptical orbit additionally influences the habitable region idea. Traditionally, the habitable region is defined as a distance range in which a planet with Earth-like environment keeps liquid water that assumes circular orbits. For elliptical orbits, the planet spends a part of each orbit within the conventional livable place and component out of doors. This ocean worldwide swings from simply inner to honestly outside the livable place with each orbit. Whether or not or no longer liquid water can persist under such conditions depends on understanding quick the sea responds to changing conditions. Water's excessive warm temperature capacity offers buffering. Oceans do now not warmness up or settle down immediately. They lag in the back of atmospheric adjustments. Despite the truth that air temperatures swing dramatically, ocean floor temperatures might vary through just a few degrees. Deep ocean temperatures may additionally barely alternate at all. Existence should exist in those greater sturdy deep layers included from orbital versions. Instead, life ought to migrate vertically following pinnacle of the line temperature layers as they circulate up and down. What have to future observations verify to settle the debate? The next observations must separate dimethyl sulfide from dimethyl sulfide. B38-4A5 and 54435 Hycean Euphorunk records information absorption features consistent with both molecule or every. They may be chemical cousins with similar spectral signatures inside the decided wavelength range. Expertise they're not same. Expanding observations to longer wavelengths might know how variations. Dimethyl sulfide has robust absorption functions among 6 and 7 microns. Dimethyl sulfide does no longer. Watching at those wavelengths may want to determine which molecule is gift. This subjects because dimethyl sulfide and dimethyl sulfide form through barely precise pathways on Earth. Dimethyl sulfide comes commonly from phytoplankton breaking down dimethyl sulfonopropionate. Dimethyl sulfide comes normally from bacterial metabolism. Locating one as opposed to the opposite, as opposed to both, would possibly constrain what kinds of organisms may also exist. All are biosignatures expertise they tell one in all are type memories approximately the surroundings. The observations ought to also increase statistical importance. Present-day self-warranty sits at 3 sigma 99.7% because of this threeson risk of mistakes. Error demands 5 sigma for discovery, which drops error's opportunity to 0.6%. Undertaking 5 sigma calls for added observation a lifetime. Every additional transit observation improves the signal-to-noise ratio. With or 3 greater transits, scientists estimate they could reach 5 sigma. 5 sigma isn't arbitrary. It's far the edge in which chance becomes so now not going that methodical errors grow to be the main situation. At 3 sigma, you would probably see a sample by means of the use of good fortune. At 5 sigma, success is basically dominated out. Any final uncertainty includes whether or not the gadgets are calibrated effectively, or whether the fashions are entire. The one's questions can be addressed through independent verification and possibility analysis methods. Unbiased verification method, different groups studying the equal facts. Scientific outcomes benefit credibility, while a couple of agencies reach the equal cease the use of extraordinary assessment techniques. Internet statistics is public after a brief proprietary period. Every person can download it and take a look at it. More than one teams have already checked out the dimethyl sulfide signal. They typically agree it is actual, although debates hold about interpretation. Greater data might provide greater to research and might help resolve disagreements. The observations must also search for other biosignature candidates. Methyl chloride is anticipated to be a biosignature on Hycean worlds. It bureaucracy at the same life and entire life organisms contain chlorine into natural molecules. Earth's oceans encompass methyl chloride produced via marine algae and kelp. Locating it in this ocean worldwide might provide independent proof for biology. Conversely, now not finding it might propose abiotic techniques dominate. Oxygen remains the gold-fashionable biosignature inside the world. Photosynthetic organisms produce oxygen as waste. It accumulates inside the environment because normal replenishment overcomes chemical destruction. Locating oxygen on an exoplanet would be effective evidence for existence. Even though abiotic oxygen production is feasible via water photosis, this ocean worldwide understanding no oxygen, which virtually suits the Hycean speculation. Hydrogen atmospheres would not acquire oxygen, even though organisms produced it. The hydrogen may want to react with oxygen without delay. Seasonal variations deserve interest. If biosignature concentrations change a life to me, an entire life that could mirror organic cycles, orbital variations, or stellar interest effects, Earth surroundings information, seasonal cycles in carbon dioxide as plant life develop and decay. Comparable cycles on some other global would possibly recommend biology responds to environmental modifications. As a substitute, sturdy concentrations over months or years may propose strong equilibrium between manufacturing and destruction. The final purpose isn't always just confirming dimethyl sulfide presence, understanding but information its source. That requires detecting a fixed of molecules that together component unmistakably to biology or really suggest abiotic processes. No single molecule proves lifestyles exists. Know how combinations of molecules that pleasant make revel in collectively with biological production might be compelling. What threshold must we skip in advance than asserting we were given located alien lifestyles? The stakes couldn't be better. Pronouncing the discovery of alien life might be one of the most profound moments in human records. It would solution a query we were given asked for 700 of years. Are we by myself? The solution ought to reshape philosophy, faith, error, and our experience of vicinity within the universe. Getting it wrong could be catastrophic. Claiming life exists when it does no longer ought to ruin credibility. Future proper discoveries might be doubted. This is why scientists call for 5 sigma reality. 5 sigma weigh the risk of being wrong through random danger is a great deal less than 1 in 3.5 of million. That is like flipping a coin and getting heads 22 a lifetime in a row feasible. Knowledge, so no longer in all likelihood you will bet the entirety that the coin is rigged. In particle physics, 5 sigma is expertise. Scientists confirmed the Higgs boson. In astronomy, 5 sigma is expertise. Gravitational waves have been added. For alien lifestyles, a few issue much less would be irresponsible. This isn't respectable coverage. Expertise instead, clinical consensus constructed through tough experience. Information teaches warning. In 1996, NASA scientists announced possible fossilized microorganism in a Martian meteorite. The information made headlines worldwide. Knowledge similarly evaluation found possibility elements. What gave the impression of bacterial fossils is probably mineral formations. What looked like natural markers might be infection. A lifetime is an entire life. Most scientists keep in thoughts the proof insufficient. The episode taught all and sundry concern to name for more potent evidence earlier than making bold claims. Extra these days, phosphine on Venus generated satisfaction. In 2020, scientists stated detecting phosphine fuel in Venus's clouds in the global. Phosphine is produced through microorganism or business techniques. Locating it on Venus recommended viable microbial existence floating in the clouds. Information reanalysis questioned the detection. The spectral signature may additionally without a doubt be sulfur dioxide misidentified. The claimed phosphine won't exist at all. Self-belief eroded from sturdy detection to unsure. Perhaps the one's fake starts at outcomes. Public hobby in astrobiology stays excessive. Expertise skepticism improved. Media outlets deal with new claims greater carefully. Scientists face pressure to be certainly fine earlier than going public. The dimethyl sulfide discovery comes with those lessons learned. The research organization a lifetime, and again MFAC extensive's warning. They may be now not claiming lifestyles has been located. They may be claiming a biosignature that requires rationalization. The distinction topics. A biosignature is assigned steady with lifestyles. It isn't evidence of lifestyles. Special reasons might also exist. The signal might be misinterpreted. The observations might encompass mistakes. Only after hard alternatives and confirming the signal a life, time can scientists don't forget claiming discovery. That technique takes a lifetime. It calls for persistence. It requires extra observations that could take years to acquire. Public conversations, stressful situations, this method. The immediately initial consequences recommend alien existence, media insurance explodes. Headlines simplify complex findings, nuance receives misplaced. The general public hears that scientists determined aliens, even as scientists really said they located a signal that could imply life. Coping with expectancies becomes important. Overlying reasons backlash. Underclaiming manner discoveries get overlooked. Finding the stability is tough. A few argue that 5 sigma is certainly too strict for biosignatures. Not like particle physics, wherein experiments can be repeated effortlessly. Astronomical observations depend on constrained telescope a lifetime. Looking forward to 5 sigma might take a long-term and entire life. Inside the intervening time, the signal is real. Ought to society look ahead to best truth earlier than acknowledging probably discoveries? Others counter that untimely bulletins motive more damage than delays. Better to be late and right than early and incorrect. This Ocean International exists at that threshold. The signal is robust, the interpretation is reasonable. Alternative reasons war to explain observations, know how doubt remains. Possibly a few elements surprising is taking place. Perhaps the models leave out crucial chemistry. Perhaps more than one coincidence is aligned to imitate a biosignature. Achieving 5 sigma could not cast off those possibilities actually, but it pushed them into implausibility. The subsequent year could be important. If more observations attain 5 sigma and if alternative reasons preserve to fail, the medical community will face a decision. At what factor does possibly end up specific? At what factor do we receive that we've detected existence past Earth? That choice will not be made with the aid of one individual or one team. It will emerge from consensus throughout the whole location of astrobiology. We stand at the brink of knowledge. 124 light-years away, a planet orbits a dim crimson celebrity. Something in its surroundings creates chemicals that in the global excellent life produces. A few aspect is occurring there that we cannot yet provide an explanation for without invoking biology. The telescope stares, the observations gather, the know-how builds. Inside months or years, we can recognize whether or not this ocean world is inhabited, or whether or not we fooled ourselves once more. Either manner, we've got entered a new era. The generation wherein locating existence someplace else is not a delusion, expertise, a scientific query with real facts and real answers approaching. The question that has haunted humanity because of the reality that we first checked out stars also can in the end be replied. We are near, so very close.